Alright, well, got all the pocket clips bent and threw them in the tumbler to knock the scale off of them after I had to heat them. So now you just see the heat coloring. They got to go in sandblast tumble one last time just to final deburr and put the finish on them, but they are good to go. They turned out pretty good. I'm pretty happy with the new dies that I got there. These are the first ones that I did. They overbent just a little bit, but got that adjusted and now they're working great. Took me, I think it was probably about an hour and a half to do 100 and some odd clips, so that was pretty nice. One thing I wanted to talk with y'all is tolerances and why I engineer my knives to be the way they are. And I mean, truly it does come down to engineering them. I gotta quit saying in these videos, really. It's killing me. Speaking of I engineer the knives because it makes one easier for me, because now all of these parts interchange and my tolerances are correct, so all my parts are easy to assemble. There's not a lot to them that I really need to painstakingly hand Dremel in a part or set a blade stop point, things like that. Bearing depths are exactly the same, so all my backspacers can be the exact same thickness and I don't have to hand fit each backspacer. So in doing that, it creates a better end product, because now you get a custom knife made in-house that is similarly set up to the way Benchmade does it. If you break a blade, you break a tip off a blade, or somehow you manage to destroy a pivot or a lock insert or a backspacer or something, or you destroy a frame sight even, and you need another one. So instead of sending it to me the way I used to do it and spending a month waiting for your knife to come back because I've got to make it from scratch and hand fit it to your other frame because the tolerances are just different on every knife. Now I've gotten to the point where I'm good enough at it that you send me one of these back and you need a frame side, I can do that. I can replace that at a cheaper cost, and it's easier on me, so it in turn costs you less in the long run, and it just makes it a whole lot easier to do that. So putting the engineering time into these, doing the lightning pockets, the lock inserts, my wife actually came up with a better idea for a lock insert, and I am designing it now into the A10s that we're doing next. So it'll be more end user adjustable. It'll basically be a lock that'll last a lifetime. That's awesome. That's pretty much unheard of. These inserts should last you the life of the knife right here. Sorry for the little burr there. But they will eventually wear. That's just the nature of something that moves. I'm building a lock insert that's actually adjustable, end user adjustable. Now sometimes I have a hard time with end user adjustment. Let me change the battery in the camera and I'll talk to you about it. So I struggle with end user adjustability sometimes. Part of me wants to engineer a knife that is 100% easily fixable through common parts that will last the rest of your life, because, you know, honestly, these are tools, and you know, you buy a wrench, you expect it to last. So the same thing should go for a knife. The other side of me says not everyone has the required skill set to adjust one of these knives if they need to. So sometimes I struggle with that, because I can't tell you how many times I've gotten a knife in return that had been fiddled with because they were trying to adjust something and they couldn't get it to work right. And then it was kind of a pain for me because I got to take the time off to fix that knife and adjust it when it's really not too big a deal for me, because honestly I do this every day, so it's no big deal. But to, I guess you'd say, the layman, they may not know the inner workings, and it's easy to mess something up. Like the HRD, for instance. It's a relatively simple, really simple little deal. It's, bear with me, grab one, a little, let me see if I can focus this, there we go, a little ball bearing set screw. Very simple. It's just a set screw with a roller bearing in it. Okay, it threads into a hole. just like anything else does, just any other screw. Now, where you run into an issue here, where the complexity comes in, that if you don't know enough about this, you'll think, okay, well, I want a super strong detent. I'm just going to turn this in a couple of turns. Well, the problem is that a couple of turns on a M3 by 0.5 threaded set screw, so we'll go 2 turns. So you can see how high that's sticking up. It's sticking up just to the height of the ball bearing. So you turn that 1, 2. Okay, 2 turns. It's sticking out so far that it'll completely ruin the knife. It'll bend the housing that the bearing is in, and it'll ram it into the blade, and it'll scratch up everything. Even 1 turn is way too much. So things like that cause a knife maker trouble. So sometimes I hesitate to make things end user adjustable just because of that fact. All in all, once it leaves my shop, it's your knife. You do whatever the heck you want with it. It really doesn't matter to me. If you want to sell it for 3-4 times what you paid for it, more power to you. If you want to paint it pink and call it Nancy, I really don't care. It's a tool. It's yours. You do what you want with it. It's just when you send it back to me for maintenance, it's kind of a hassle sometimes. So that's why I hesitate sometimes with end user adjustment. There's my soapbox talk on that. But back to engineering. I spend a great deal of time engineering these so that they work well. My whole goal in life with this whole business is to make the best possible tool on the face of the earth. It's my whole goal. That's why you see every single batch that I'm doing something innovative, something new, something that makes it better. I don't step back and I don't charge any more for it if I've already told somebody a price, because it's not fair. But I'm constantly improving. I'm always trying to fix things, even if they don't really need to be fixed. And it gets me in trouble sometimes because it does take a lot longer to constantly improve every single batch. Sometimes it would be nice to be able to just do this 500 times and call it good. But it's just not in me not to make things better. So I'm always constantly improving. So with that said, we are fitting, or I am fitting, I should say. I need some gremlins or something out here. Final fitting the blades to the locks, to the stop pins, doing the last little bit of adjustments there, and bolting all the frames together with the blades and the detents so that I can profile them. Got these 3 guys here done. And let's see if I can get it out of here. Fit them together, put all the parts together so I know where they are. I gotta do the final profile all the way around on the belt sander, deburr, carve in the thumb slot here so it's easier to unlock. But they're centered. See if I can get it to focus on that. And they flip nice. They're nice and smooth. Now there's no oil on these, which is always gets me because I love it. How smooth they are now with the stuff the techniques that I've been using that make them so much smoother even without lubrication. Oh, speaking of lubrication, I thought you guys might enjoy this. Well, that sounded odd. Scratch that. I just developed my own lubricant for the knives. I've always had a hard time. I've never liked thin oil, like gun oil, anything like that. All my guns, I've always greased them. I've never oiled them. I always grease everything. Problem with grease is that it's thick. It's kind of nasty sometimes when you're trying to clean it. It's kind of a pain in the butt. Oil, to me, it doesn't last long enough, the thin oil, because it evaporates, it collects pocket lint easier, and then it gums up pretty quickly when it's real thin like that. Grease, it kind of almost acts as a barrier, because a bearing will ride around in it and build up a dam around it, and then it kind of, this crap sticks to the outside, but never really gets to the inside, because these bearings really aren't circulating very much. So I did the best of both worlds. I developed this grease, and I just kind of make it here in the shop just because it works really well. I don't know if I'll give you the details of what it is, but it's nanoparticle technology with machine tool type lubrication properties. So it's a high pressure lubricant with nanoparticle in it that will basically create little microscopic ball bearings that are 0.002 micron in diameter, and they are cylindrical. So it's kind of neat. It was interesting. I've been kind of researching chemical compounds and crap like that, trying to figure this out. And so far, I've done 10 knives with it, and I've started originally using it on my automatic, and it's awesome. This thing, it's difficult with the button lock and the bronze bearings in here. Sometimes difficult to keep it lubricated and not collect a bunch of crap inside of it. With this stuff, it's like a, oh man, it comes out almost like a crayon, like paste, like a pastel mark or pastel pen, pencil, or whatever you call it. So it's real thick and not so much viscous as it is pasty, and it sticks really well. And the neat part about the nanoparticle stuff inside of this is that it embeds itself in the micro pores of the steel. So even once the oil that is in this kind of dries out and goes away, it's still self-lubricating, kind of like the way graphite or Teflon coating would be. So it works pretty good. So I've been testing that for about 2-3 months now, and I've been enjoying it. So it went into production. It goes into all these knives. So that was pretty cool. I thought you guys might enjoy that. I know you guys like the little things. Well, I'm going to get back to work, and I'll get back with you. I may just upload this video now so you guys got something to watch while I'm doing the rest of this. A real quick note on that. I had an idea I forgot to tell you guys about. I've told you about it before, I guess, but I haven't really shown you actually how it worked out. I make my pivots. These are AKS pivots originally, and then I machine them out and everything. Well, what I do is I'm machining the head eccentric to the barrel. So it's actually 3/1000ths off in one direction. So when it spins, it actually lopes like a cam in an engine. Then I also make the pocket for the pivot eccentric as well, so it locks the pivot screw in. So what you can see, let me zoom in and manipulate this, so that when it drops down in, it locks. Now I can't twist it. And that's good to go. Now the pivot won't twist or rotate. It only took 3/1000ths, so it turned out pretty cool. Like I said, always engineering. Right, I figured I would amend the video here to show you guys that there is quite a bit of hand fitting when we're making these knives. Just because you use CNC doesn't mean that these aren't custom made. I have a whole drawer of 65 knives here, and every single one of these gets hands-on attention. So they are still pretty much handmade knives. It's just I do a lot more programming on the computer now than I did before. It just makes me more efficient and allows me to make things not so much better, but faster, which is nice because I'm always behind, as you guys probably already know. So right now what I'm doing is I mismachined this center jimping spot right here. I still need to profile this, but as you can see, there's a fair amount of material, about 30/1000ths that I missed in there. I only machined it to 1/8 inch when I should have machined it to 3/16 in this one. These ones are 1/8. So what I'm doing is manually machining those out, and then hand fitting the jimping with the 4-arm tool with a carbide burr. So it looks like this when it starts, and then when it's finished manually machining, I just knocked most of the material out, and then I'll hand fit it on the 4-arm. You can see there's a little bit right there left. When I'm done, they look like, I don't have any that are put together, but here's a backspacer. Come on, there we go. And when they're done, sorry, it's a little shiny, it's hard to see. They're nice and smooth, no burrs, all that. So that's hand fitting for you. Well, I am finishing up this stuff. I sent out an email to everybody to apologize for the delay, but things are getting pretty good around here. I'm fitting the last of the backspacers, I got about a half hour's worth of work on every knife, and they're finished. So it just adds up when there's 65 knives. But I'm just cranking through these things. I just go through with the 4-arm and double check every single part, knock off any burrs, adjust the tolerances where need be, like in the jimping, and polish up all the spots on the edges, deburr everything, cut the detent ramp into the blade. Final fit how far I want the blade to be into the frame, so you can't catch the tip of your finger on it, or too far to where you can cut yourself on the backside. But this one needs a little bit of hand fitting, but it's doing pretty good. So yeah, that's what I am doing now. So I will upload this video whenever I can get a free second, and try to keep you guys updated. Next, we are going to do A10s and the couple of orders that I had for OSF 3.5 before I close the books on all that stuff. I'm excited about the A10s because you guys have been waiting forever. So I'm really looking forward to getting you guys taken care of. And then also I'm really excited about the OSF. That's the open source folder, a 3.5-inch blade flipper. Posted some pictures on Instagram of my CAD files. I just did a couple of small modifications, and then once I make the small batch that I'm going to do, I think I'm only going to do probably 10 of them. I've got 3 or 4 orders for them already that I need to get rid of. What I'm going to do, let me see if I can make it so you can see me. Hey, there we go. So what I'm going to do is, once I get the water jet stuff cut in for the frames, backspacer, blade, all that fun stuff for the OSF, I'm going to cut those out and do the video and the work in progress and all the pictures and stuff, and then I'll release the drawings and all of the video work, so that if anybody wants to get into making folders, they can just grab the drawings and print them out and make themselves a folder. The only thing I ask on that is it's open source, modify it however you want. I just don't want you guys to sell it because I sell them. But it's just a learning tool, so I'm going to put that out there for everybody. So I'm pretty excited about that. And that's about it, guys. All right, well, back to machining. Hope you guys all have a good week. God bless, and on to the next video here in a couple of weeks. Alright guys, another week of the Hoback shop. I am finishing lots of frames. Right now I am measuring bearing pocket depth. Well, I sure hope you can hear me with the sound of the router going. Just cutting the last batch of lock side frames. So right now what I'm doing is just marking the depth of each bearing pocket, seeing if I have any pieces that need to have any major adjustments. I'm measuring them in 5/10 increments. So I got a little bit of variance, about 0.003 variance across the board, which is okay. I'd prefer 1/1000, but I'm not as careful as I should be with setting my tool height offsets. So live and learn. I'm going to adjust that next time the next run I do. So there's going to be a little bit more hand fitting on this stuff, but it shouldn't be too bad. It's only a couple thou, so I'll just hit them on the surface grinder. So basically, I'm just coming over to my little height gauge, and let me set up the tripod and I'll show you what I do. Pretty straightforward. Grab a frame here. So, it's a frame. Gotta wipe it off. Hopefully my battery doesn't die. And then I put it on the edge because I've got a couple of screws right here that interfere. So I just put it on the edge. Bring it over right next to the bearing pocket on top. And zero out. And then drop it down into the bearing pocket couple times, and of course my air compressor kicks on, and you can see I'm averaging 68 thousandths on that, which is perfect. So we'll just go from there. So it's the most incredibly boring job on the face of the earth. So I'll show you some more when I get done. Alright guys, so we're going to talk about tolerance stacking. It's a well-known thing for most machinists. I've only been machining for 3 or 4 years now, so I'm always constantly learning, going on forums. That helps a lot. There's a lot of information if you just go into Google and type in machining strategies. Read white papers that some of the machining companies, the tooling companies like Ister and all those other places. Tormach's got a lot of good information. So I've been learning a lot about machining in general and holding tolerances. So this batch is my best yet, but what I wanted to talk to you about is, I guess in the industry, the term is tolerance stacking. And the basic premise of that is that you have on one part, say this pivot, you have a tolerance, which is how large or how small the part can be from your drawing. So if the barrel of this pivot is supposed to be exactly 0.250, your tolerance, say I have tight tolerances and it's 5/10 plus or minus. So that means it could be 0.2505 or 0.2495. So you have three different choices there, roughly within tenths, that you can have this. Where your problem lies in you get tolerance stacking is that all these points plus or minus add up. So if you have a 1/4 inch pivot that is 5/10 too small, so 2495, then you have a pivot hole in your frame that is 2495 as well, but then your other side is 2505, and then your blade is loose. Say it's 5/10 loose, so 2505 as well. What you run into is you start running into tolerance stacking, which means you have to add all of the tolerances together, and that gives you your total amount of tolerance that you have allotted in a, most of the time I believe this isn't a mechanical structure or something that you're building that has multiple parts. So what you get is tolerance stacking, you get loose. So you have to know where it's okay to have plus or minus and where it's not okay and where you should just scrap the part. I run into issues with keeping tolerance if the tool's dull. A 1/8 inch end mill, I use an 1/8 inch end mill quite a bit. It'll run about one plate of parts. It's about 21 frames front and back with all the little operations that I do in it. But by the end of that, it's actually fairly dull. So at that point, I toss it out before I go to the next plate. Now when I go to the next plate, if I don't toss out that 1/8 inch end mill and I want to bore out, let me see if you guys can see this. I actually do a, come on, focus. Today. Okay, this stop pin hole, I actually do a helical interpolation with a 1/8 inch end mill and bore that hole. So by the end of the plate, these holes are actually getting smaller because the end mill is not removing as much material. So then I end up having to go through and clean them up with a Dremel or a reamer. So I end up having work later on that I shouldn't have to have if I just change the tool out. A $4 tool, if I changed it out halfway through the plate, then I wouldn't have to mess with this for an hour later on. So tolerance stacking, things add up. If your hole's loose here, it's loose in your blade and it's loose in the other frame, and then your backspacer's undersized or oversized, then you have all sorts of tolerances that are adding up to a bad tolerance, I guess you'd put it. So what'll happen is if you have all these tolerances set up and they all work one way, like the minus side, or you have one that's a positive and all the rest are minuses, then you end up getting a knife that doesn't work properly, or a part or a fixture or something that's not working properly because you gave it too much tolerance. So you have to know where it's acceptable. So that's something I'm learning. I found it pretty well. Knives, in all honesty, you don't have to work into thou range. Plus or minus 1 to 2 thousandths total tolerance stack is okay. Really, these are not, as much as I'd like to say they're high, super precision ground parts and everything, they're not. You're boring a hole in titanium and running a bearing in it. That right there negates anything that you want to say about tolerances, because titanium's soft, it's not a good bearing race, so you end up, it galls, it creates its own race, so you end up having to compensate with your bearings and your backspacer's thickness so that when the bearings break in, the backspacer is still the proper thickness. There's a lot to it, but in all honesty, 1 to 2 thousandths total tolerance stack is more than adequate. If you held a thou tolerance all the way around, through everything, your total tolerance stack, this would be like NASA grade stuff. It's not usually necessary. So that's what I've learned. I started reading up on tolerance stacking because I'm designing a real small benchtop CNC lathe that will produce pivots for me. So I've been learning about linear ways and ball screws and stuff like that, and tolerance stacking is really big when you're building a machine tool, because the more plus or minus tolerances you have, if they all lean one direction, the less accurate the machine is going to be. And I'm hoping to build this machine to hold tenths, not thousandths, so everything has to be perfect. So let me give you a rundown of what I've got done so far on the frames and what I am finishing up. I am finishing up the last plate of Loctite frames today, so that's awesome. That's been a lot of machining. Blades are pretty much done. Got to cut the locks and then put the finish on them. That shouldn't take me too long, maybe a day or two. All those are completed frames. They all have the lock inserts set up. Lock inserts were much easier to do this time because I changed the way I did them. And the next batch of knives that I do is actually going to be different from this one as well, because I've discovered a better way to do it. After talking to my genius wife and running ideas by her and stuff, she came up with a great idea, and I'm going to run with it. So instead of the insert coming all the way to the surface of the blade, or of the frame, it's actually going to be a slotted, there's going to be a strip of steel that's pocketed in here, about 100 thousandths depth, and there's going to be two 440 screws in slots, counterbore slots, so that the insert will be fully adjustable, and it'll last the lifetime of the knife. You'll never have to worry about it again. These ones will as well last the lifetime of the knife, but they're not as adjustable as this new one that I've developed. So we're going to switch over to that. I'm doing A10s next, so I think we're going to do 60 of them. So that's pretty cool. Other than that, backspaces are all done. I'm just cleaning up the edges right now. And I got to wait until these frames come off of the mill so that I can build my clip bending fixture to bend these bad boys up. I'm going to be able to do 3 at a time on my arbor press. Right now I'm doing them 1 at a time. You heat up one edge, bend it, heat up the other edge, bend it, dip it in water, flip it around, bend the other edge. It's kind of a pain. It takes about 6-7 minutes to bend each pocket clip. The way I'm going to set it up is it's going to be a multi-bend die, and I guess a die and a press head or something like, I don't know what you call it. But you'll heat up the whole clip with the torch, and then you'll bend all 3 of them at the same time, and it'll do all 3 bends. So that'll be nice. That'll save a lot of time. And it'll be repeatable, which is always nice. Makes life easier. Repeatability when you're doing lots and lots of parts is very nice, because it just is. So, yeah, that's it. Sorry to ramble on about tolerances, but I try to hold pretty good tolerances with all these parts, and it's always interesting when it comes out and it works perfectly the way you wanted it. It's just awesome. This is one of the first times that I don't have any knives that I've struggled with getting loose or tight with the blade in the frame because the tolerances are a little off. Usually you have to end up hand fitting a bunch of stuff. These ones just fly together because I've been holding tolerances a lot better. So that's pretty cool. Something to keep in mind when you get into knife making, if y'all are. Tolerances are actually pretty key. You don't have to hold NASA grade tenths tolerances, but a couple thou makes a big difference. Alright guys, I'll keep you updated. Alright, so I realized that I've never, in any of the videos, gone over how I cut locks and how I fit locks. I figured there's not really a lot of information out there on it, other than cut it at this angle, fit it until it fits kind of thing. You don't really hear a ton about it, so I figured I'd kind of give some detail on how I do it. So what I'm doing here is I'm doing it a little differently than if you were just cutting 1 or 2 or 10. Since I'm cutting 65 of these things, I really have to try to make it efficient. And how I'm doing that is, since I have a lock insert, it'll be a little different than if it was just straight tie. But the way I'm doing is I'm taking all these blades and I'm setting them up, and I'll go show you my setup. I think I've showed you all my lock cutter. Let me grab a blade. And I'll show you my setup. I machine my lock cut. Bear with me here. Set up the tripod. So I set it in here. I machine my angle here, which is 7.5 degrees. It's just a number that I use. It works for my knives. Anywhere from 8 to 7 degrees is pretty good. You're not really going to have any issues with either one of those. I've done them all. I just settled on 7.5. It seems to work well. So the basic premise is that this block of aluminum is cut at a 7.5 degree angle, and then these holes are machined in there. And then I have an adjustment that allows me to tilt my blade on the pivot, and then this part clamps it down, and then I just put a clamp on the edge here to hold it, and then I machine this in. I'm doing it differently than you all would if you're just doing a handful of them with titanium locks, in that I'm machining in a certain depth and then I'm leaving it. I'm not actually fitting this angle to the lock bar like I normally would. I'm actually fitting the lock bar to that because I have an insert that I can grind back. I like to machine the lock in because it's a lot more precise and it's a lot harder to mess it up because I'm only moving a thou at a time. So I'll go over, I'll cut one of these, I'll show you what it looks like, and then I'll come back to you. But you can see this is just it's machined straight. And then I'll cut the angle on here and I'll show you. I figure I'll show you guys how I'm doing it, how I set it up and everything. So take said blade, got a little pivot that I built. Make sure there's no grit or anything in there. And then slide it in. Make sure I push it up against the screw. And then I tighten it down. Okay, now it's held in. I'll put a clamp on there. Let me move the camera so you'll be able to see a little better. Hopefully, I can zoom you in a bit. It's kind of hard. I don't have a lot of space here in the shop, so. Okay. So I'm gonna run the end mill. It's just a wore out tip ball nose end mill, but the side cutters are still good, so I reuse them. So I'm gonna cut in to my 0 depth that I have set on my DRO, and then I'll show you what it looks like. Alright, so that's the basic premise. I'll take it over to the bench and show you. Okay, so before I go too much further into fitting blocks, there was a couple of things I wanted to kind of show to you guys. Forgive the rust here, I gotta throw these back in the tumbler. So after I cut the lock face, I cut it, I think I told you, 7.5 degrees. That seems to work well for me. What I like to do is, hopefully you can kind of see that. When I cut this lock, I come in with the Dremel tool and I round this edge over. I put like a 20 thousandths radius on this. I also do the same thing for the lock insert, and then I round this tip. That'll really help if you have any sticking lock issues. I don't really have to deal with it with the steel lock inserts, but if you're running titanium, round the leading edges of both lock faces, and that helps a lot. So yeah, when I get finished cutting all these locks, I'll come back to you and show you how I fit the inserts. All right, so pivots are done. See if I can focus in on these. A little dirty, but you get the idea. And I just got done building a fixture to grind these to length. Right here. So this is precisely drilled and reamed, holds like 102 pivots. Basically you just stick the pivot down inside and it sticks out on the end and you throw it on the surface grinder, grind it off. Works really well. So just got done with that. I need to deburr the edge of these a little bit, and right now, yeah, can't really see it, but I'm machining a set of dies that will bend pocket clips for me, 5 at a time, on the arbor press. So I'll start machining that and I'll show it to you. Alright, so I got this bending die done. Mind the back, it was an old fixture that happened to be the right thickness of steel, so it's got some weird holes in it. I made a couple of changes. I'm running it again right now, but it actually turned out pretty good for the bend. I just needed to adjust. You can see it bent it. So I brought the height down a little bit for that bend, and then I brought the first bend out away from that hole a little bit so the screw wouldn't interfere. But it bent it real nice. Or bent it real nice. Excuse my awesome language skills here this morning. But the die turned out pretty good. It's got a couple of spots here. These aren't gouges, it's actually from the previous end mill. I didn't give myself enough of a offset for the roughing and the finishing pass, but I've got that fixed now. And the basic premise is you just stick it in the arbor press, pop a clip in there, you put them in upside down, and then you put this one over the top while it's red hot and pull the arbor press down and squish it. Once it's done, you got a bent clip that looks like this one. Let me see if I can get this thing to focus a little better. There we go. I tightened up the radius on this bend here. Let me grab the die. So this here, it's got a little bit of a radius to it. So I tightened this arc up a little bit so it wasn't such a sweep, and then brought this bend down a little bit so that the tip of the pocket clip would come up a little higher and a better sweep. But yeah, so far so good. So now I'm just gonna finish running it the other way. I did change up the die. I made it 3/8 of an inch all the way around larger, and then I added some 1/4 inch by 2 inch long dowel pins on each 4 corners, and then there are through holes, so the top die, this one, can slide on top of those dowel pins and just drop down and it'll be aligned. The clips actually screw on to these threaded holes here, and then I forgot to pocket the top of the screw head here, so that'll make it easier. You'll be able to put 5 pocket clips in here. They'll all align with the dowel pins, drop down once you got it hot, and squeeze it, let it hold for a few seconds, and voila, then you got a pocket clip. So turned out pretty cool. I'll let you know when I get the other one done and show it to you.